Iniziamo.
Buon pomeriggio a tutti, il mio benvenuto a tutti i partecipanti. Io sono Marco Adami, un socio AFI di lunga data e ho il piacere e anche l'onore di fare il moderatore in questo webinar che, come sapete, è il secondo dei 4 webinar che fanno parte però a tutti gli effetti del Simposio AFI. Quindi benvenuti, vi porgo anche i saluti del dottor Bruno, presidente dell'associazione. Io non voglio rubare tempo alla parte tecnica perché abbiamo un programma abbastanza intenso. Abbiamo anche alla fine previsto una sessione di domande e risposte. Chiedo ai partecipanti di utilizzare appunto lo strumento domande e risposte che avete in basso al vostro screen. Potete farlo in qualsiasi momento, poi alla fine modereremo la sessione e faremo appunto questa parte di domande e di risposte. Vi pregherei le domande che vengono fatte ai 2 relatori di lingua inglese, forse è meglio se vengono fatte direttamente in inglese, così evitiamo qualsiasi magari misinterpretazione da parte mia, cose di questo genere. Bene, e come avete visto, oggi parleremo di un argomento che è molto caldo e lo è diventato ancora di più dopo la revisione dell'Annex 1, quindi parleremo di, io dico CCI, quindi Container Closure Integrity Testing. È un argomento molto importante e come riportato nella locandina, praticamente noi vedremo in questo webinar l'evoluzione che c'è stata con l'introduzione del nuovo Annex. E sottolineo solo che evoluzione è la parola che io preferisco, anche se so che molti colleghi parlano di rivoluzione che è stata portata dall'Annex 1, ma questa, vabbè, è solamente una questione di terminologia. Noi avremo 4 presentazioni, affronteranno sia aspetti tecnici sia aspetti regolatori. Io non entro nel merito di queste presentazioni perché so che il dottor Stefano Menghini, che sarà il primo relatore, che introdurrà l'azienda M3, ma parlerà anche dei brand che l'azienda distribuisce nel settore pharma, di cui sono rappresentanti gli altri 2 relatori. Avremo anche uno dei 2 relatori, appartiene anche a ASTM, che è l'ente normativo statunitense, e quindi avremo l'opportunità di sentire un po' il polso della situazione anche da parte di questo ente americano relativamente all'importanza della progettazione e dello sviluppo del packaging primario come barriera e quindi in ultima analisi ciò che porta poi o contribuisce meglio alla qualità del prodotto finito. Quindi io direi che presento rapidissimamente il dottor Menghini. Dopo aver completato gli studi tecnici, so che ha avuto le prime esperienze nel settore laboratorio a partire dall'aprile del 1999, poi ha acquisito esperienze mano a mano crescenti di gestione del prodotto e delle vendite nel settore di vendita degli strumenti da laboratorio e poi come product manager, e dal 2008 egli è sales manager di M3. Stefano, prego.
Grazie mille per questa introduzione, ringrazio il dottor Marco Adami e tutta l'organizzazione AFI per l'opportunità che ci danno di condividere sia le esperienze di M3 oggi che il nostro nuovo brand SIFA, le sue tecnologie e soprattutto la sua grande competenza, e spero che oggi l'audience sarà sicuramente ben informato e soddisfatto delle novità. Sarò velocissimo, ci tengo a introdurre M3 che oggi
Stefano,
rappresenta.
chiedo scusa, se mette in modalità presentazione riusciamo a vedere meglio.
Ti ringrazio per l'aiuto, spero
Ecco
che
qui,
ora possiate
perfetto,
vedere.
grazie.
Perfetto, grazie a te. Dicevo, sarò rapidissimo, presento l'azienda per la quale lavoro da più di 15 anni. L'azienda si chiama M3, un'azienda che è stata fondata dal signor Maggioni, attuale proprietario e amministratore delegato. Oggi siamo un gruppo di lavoro che ha superato da poco le 25 unità e siamo presenti su tutto il territorio nazionale e nel Canton Ticino. Abbiamo presso la nostra sede sia un laboratorio di assistenza tecnica, poiché ci occupiamo di tutte le attività di post-vendita, e anche di un laboratorio applicativo. Questo serve per crescere innanzitutto al nostro interno con le competenze che il mercato richiede giorno dopo giorno e anche per aiutare i nostri clienti. Siamo attivi da sempre nel settore farmaceutico e negli anni abbiamo sviluppato anche altri settori a cui possiamo dire che il nostro business afferisce. Sicuramente il mondo anche della chimica ambientale, il mondo agroalimentare, la cosmetica, e da sempre seguiamo con un buon bilanciamento tanto il cliente pubblico quanto il cliente privato. Prettamente nel settore farmaceutico proponiamo 4 marchi. SIFA è sicuramente il primo, ne parleremo sicuramente oggi su quelle che sono le tecnologie di controllo sul packaging. Rudolf è un'azienda americana molto presente nel settore farmaceutico, e anche Erveca, un'altra azienda storica del settore farmaceutico tedesca. L'ultima, ma non meno importante, è il brand Eco, che ha una grande esperienza nel mondo del controllo della presenza di ossigeno o produzione di CO2 e nello specifico hanno degli strumenti proprio per il controllo del contenuto di ossigeno all'interno dei blister. Qui un esempio molto molto rapido di quelle che sono le apparecchiature delle quali vi ho appena descritto i produttori, e senza, diciamo, ulteriori approfondimenti che posso rimandare a più tardi con eventuale sessione di domande e risposte, ci tenevo semplicemente a sottolineare che molto spesso siamo in grado di affrontare anche dimostrazioni pratiche sia della parte software che della parte hardware della strumentazione che proponiamo. Ci occupiamo personalmente di tutta la fase di studio per capire qual è lo strumento più corretto, l'installazione, tutta la parte di qualifica in sede di installazione e anche tutte le qualifiche post-installazione. Vi ringrazio, vi aspetto sicuramente al Simposio AFI, saremo presenti come espositori e per il momento vi ringrazio per l'attenzione e ripasso la parola al dottor Marco Adami.
Grazie molte. Bene, adesso grazie per questa introduzione. Approfitto anche per dire che tutti i relatori hanno già dato l'autorizzazione alla pubblicazione delle presentazioni, quindi i partecipanti potranno avere le slide in formato PDF. Bene, adesso passiamo la parola ai rappresentanti di SEFA. So I ask Evelyn and Philip to start their presentations and to introduce themselves at the very beginning. Thank you.
Hi guys, I'll just share my screen and Evelyn will turn her camera on as well.
Okay, we can see your presentation.
Perfect. Perfect. Okay, so the format, I'm just going to give everybody a short introduction to the format of the webinar. I will talk a little bit about the agenda, and then Evelyn will take over and do a short introduction to SIFA. Okay, so the webinar what we plan to cover in the webinar is the general broad topic of package leak testing insights. In terms of the agenda, we plan to roughly split the webinar into two parts. The first part will be CCIT, navigating involving industry standards and measurement principles. The second part, we will focus on blister package integrity from there. Okay, so the agenda then. So as I said, Evelyn will take over shortly from me and cover the introduction. From there, I'm going to talk about Annex 1, European Annex 1, and some of the updates specifically around the leak testing and inspection side of Annex 1. The next section, I'm going to look at a number of testing standards, a number of standards. So the standards surrounding the ASTM and the standards relating to packaging for that, and also some of the content around USB 1207. From there, we plan to pick out a couple of relevant testing principles for the industry, one being the vacuum decay standard. And then the last section, what we will do is we will look at the vacuum deflection, and that will be section 2, and that's primarily around the blister package testing and CCIT around that. And then lastly, we'll look at any questions and go from there. Okay, so from now, I think I will hand over to Evelyn.
Thanks, Philip. If I can just, Sandra, would you mind blocking the video? Yeah, Sandra, it's saying the video, I think, has been stopped by the host.
I'm working on it.
Oh, thank you.
Can you do it?
You cannot start your video because the host has stopped it.
Let's check.
Okay. Oh, start my video. Perfect. Thank you. So, good afternoon, everybody. To introduce myself, my name is Evelyn Owen. I am the Area Sales Manager at SIFA for Central Europe. Yes, SIFA was established, with me, yes, SIFA was established in 1981 as a dedicated machine manufacturer for the pharmaceutical industry. We are headquartered in Belfast in Northern Ireland, and this is where all of our production and all of our software teams are based. We are also, since June 2013, part of US firm, the TASI Group. So we provide solutions in 3 key areas: in CCIT and leak testing, in blister packaging, and in deblistering. Yes, so apologies for the delay. Since 2013, we are part of the US-based TASI Group. So we form part of the Packaging Integrity Division, along with Alps Inspection, Castle, and Bonfiglioli Engineering in Italy. So in terms of SIFA and packaging solutions, we provide benchtop packaging solutions, including tooling, and design services to offer flexibility and high quality blister packs using a wide range of different packaging materials. Within our range, we offer 3 main solutions. We have our Easy Blister, our Easy Blister Plus, and our Easy Med Pack. So all 3 machines function using a 3-step process with forming, sealing, and cutting. And all are ideal for clinical trials and for R&D purposes. The 3 solutions function with interchangeable tooling so that all of the machines can form using both thermoform and cold form. So in the image in the top left-hand side, this is our standard Easy Blister. A modified atmosphere packaging option is also available on the Easy Blister. Then we have the Easy Med Pack, the bottom left image. This is our packaging solution for packaging medical devices. And then on the right-hand side, we have our Easy Blister Plus. So our Easy Blister Plus is our newest addition to our packaging offerings. Our Easy Blister Plus is our 21 CFR Part 11 compliant solution, which provides pharma manufacturing companies with the flexibility to create low volumes of blisters within a 21 CFR Part 11 environment. As part of our packaging division, we also offer a package design service. So along with our design engineers, we will work together with you to, I suppose, to advise and create a pack design prior to manufacturing the tooling that is then needed for the equipment. So in terms of deblistering, we have a range of automatic, semi-automatic, and manual deblistering solutions for safe recovery of valuable products. We have our roller-based solutions. So we have our press-out manual wide and our press-out semi-automatic, which can deblister up to 30 blisters per minute. And both use fully adjustable tooling to allow compatibility with a wide range of package designs. We then have our cutting technology solutions. So we have our Press Out Universal and our Press Out Universal Mini. Both of these are automated and tooled systems, which can deblister up to 50 packs per minute. And are ideal for child-resistant packs and fragile products. So in terms of our leak testing solutions at CIFA, all of our leak testing solutions are non-destructive and deterministic solutions for leak testing a range of different container types. All of the solutions that we have are also 21 CFR Part 11 compliant. We have, first of all, our CCIT solutions, our MultiQ and MultiQ HD. So these machines or these solutions use interchangeable tooling to leak test bottles, vials, ampules, pre-fill syringes. They can use both pressure decay and vacuum decay to find leaks as low as 1 micron with a test time as low as 10 seconds. We also offer, as part of our service, we can offer feasibility studies on our MultiQ range, as well as the other leak testing solutions that we have. Moving on to our VisionScan 3D. So our VisionScan 3D is our leak testing solution specifically for blister packs. Again, it is non-destructive and deterministic. It uses a 3D laser and vacuum deflection principle to measure movement of lidding foil. It's a toolless machine, and which can test multiple packs per cycle down to 5 microns. And finally, in our leak testing range, we have solutions for flexible packaging. We have our PackScan and our MediScan. So our PackScan can test pouches and sachets using force decay. We can test from 4 up to 10 packs simultaneously, depending on the dimensions of the pack. And we can test, well, we can find leaks down to 10 microns. So with the PackScan, we can test packs up to a pack depth of 45 mil. For packs between 30 mil to 200 mil, we have the MediScan. So the MediScan will use the same principle as the PackScan, so it is also using force decay. However, it's a benchtop version. Again, toolless, but we are testing 1 pack at a time. So I hope that has given you a bit of an overview into the different solutions that we have at CIFA. Obviously, any questions or discussions that you would like to have after this, we'd be more than happy to have those discussions. I will pass you on now to my colleague, Philip. So Philip will lead the next part of the presentation. So thank you.
Brilliant, Evelyn. Thank you. So just a little bit about me. I'll give you a short introduction about myself. So my name is Philip Cooper. My job role here at CIFA is that I'm head of technology and new product development. And in terms of my industrial experience, I've worked in the industry now over 24 years within the pharmaceutical machinery space. I've been involved with the ASTM and specifically around FO2 primary barrier packaging on that committee for the last around 14 or 15 years. And for about the last 10 years, I have also been the chairperson of one of the subcommittees, which is package integrity. And I'll speak a little bit about it, the ASTM and that committee and subcommittee later in my presentation. My expertise, as I said, is around primarily around leak testing, inspection, blister packaging, deblistering, and also just generally international standards. Okay, so this next section, I plan to talk about Annex 1, give a brief overview of where Annex 1 sits in the whole larger European legislation. I will then go on to talk about some of the changes to Annex 1 and specifically the changes around the definition of some of the leak testing requirements and things like that. Okay, so we'll maybe start at the very beginning. We want to talk about good manufacturing practice and the definition around that. So you can see that this is the definition taken from the EMA's website. So in terms of the overall European legislation is broken into many volumes. You know, there's 10 volumes. But not all 10 volumes are actually legislation. There's only, I think, 5 or 6 are actually full legislation. But within the industry, that there's all these volumes are used extensively throughout the industry, and depending on what you're manufacturing and producing. Today, we're only going to look at a very small part of Volume 4. And as you can see, Volume 4 itself is even split into a number of parts. So Volume 4 is split into 4 parts, and then there are additional annexes, and also then there is an additional other documents and guidance that people will use as well. But we're only going to focus on a really small corner of it, which is Annex 1. So As you can see, there are many annexes. There are 21 current annexes in Volume 4. And as I said, we're only going to talk about a small part of Annex 1 itself. So you can see the latest revision of Annex 1 was launched last year towards the end of August. And it's for the manufacture of sterile medical products. We are going to dive deeper into Section 8. And even when we look at Section 8, we're only going to look really at 822 and 823. So, as I said there a few minutes ago, that Annex 1, the latest revision was in September 2023. The previous version, as you can see, was very vague and didn't have much detail around integrity testing. This new version now, they have expanded on that and included and expanded on a few of the definitions, and also then they have also looked at the volume and what should be tested and not tested 100%. So one of the things that they have expanded on is the definition of closed by fusion. As you can see, they've expanded the two original containers now into small and large parentals, so basically small and large IV bags, blow fill seal, and also form fill seal as well, have been directly named within the standard. But there's obviously other containers within the industry that are closed by fusion, and also there are under this new annex. And the other big change is now the definition of what should be tested and the frequency of the testing. So anything that's equal or less than 100 millimeters and it's closed by fusion, it should be subject to 100% integrity testing now, using a validated method. The one important note that they also call out is that a visual inspection is not an acceptable way now of doing an integrity test. And then for containers that were over 100 millimeters or milliliters and are closed by fusion, the Annex 1 now says that it's acceptable that they don't need to be 100% inspected, but as long as you have a valid sampling plan in place, perhaps, so you may be sampling at a certain frequency with a certain quantity. But as long as that sampling plan can't be scientifically justified, that's now covered and accepted within Annex 1. This table just highlights, is testing required? Is 100% testing required? Is it not? And then I've just highlighted here on the side, there's some common CCIT methods that can be used for various container types. Okay, so that covers really briefly some of the changes to Annex 1, gives you hopefully an overview of Annex 1 and where it comes from, and also where it sits within the legislation. I'm now going to talk about some more standards. Specifically, I'm going to talk about the ASTM, a bit about the structure of the ASTM, and also then USB 1207 and some of the related USPs as well. Okay, so in this section, I'll talk about two subcommittees really, F02 and D10, which are the two committees I'm going to talk about. And as I say, I'm going to talk about 1207 CCIT as well. Okay, so the structure of the ASTM. So the structure of the ASTM is a multi-layered structure. At the top of the structure and where the standards are actually published and approved is the society level. Below the society level then is what was termed the committee level. And today I will talk about two committees, FO2 and D10. Below each of the main committees, then there are many, many subcommittees, and I will show you the structure in a bit more detail of each of these. And then below each of the subcommittees, there is a work group level. So for anyone to produce a standard, it starts off live as a work item within the work group. Once it gets to a point where you have completed the necessarily interlab studies or the structure is complete, it then will go to subcommittee level, which the subcommittee people discuss and vote on. Because it's the consensus standard, you can get then constructive feedback from many areas of industry to form a really nice consensus standard. Once it's past approval and the voting process at subcommittee, it will then move to the committee level, and it goes through a similar process. Once it's past committee level, it then goes to society for final approval, and then is ultimately then published and released to the general public. So that's kind of the process and the structure of how a new standard is developed, and the release and process. Typically, the time frame from initiating a new work item to releasing a new standard is around about 2 years, maybe 3 years, depending on the complexity and maybe even the feedback from the consensus group as well. STM has many committees, and as I said, I'm only going to look at two: D10 packaging and FO2 primary barrier packaging. But I think there's 150 or 140 something standards or subcommittees overall. In terms of D10, as you can see, D10 is the committee that looks after packaging, and all the packaging standards are found in here. And there's, it's everything around packaging. The one of interest that I always like to look at is this shipping. So that's your final product has to be shipped, and all within these D1020 is all the shipping and vibration standards. So it's all the altitude testing, it's all the vibration testing, it's all the temperature testing standard there. And you can see there's other subcommittees there that I just haven't put a graphic against as well. The other subcommittee then I would like to highlight is the one that I'm directly involved in, is primary barrier packaging. Primary barrier packaging then again has a number of subcommittees that sit under the main committee, as you can see. And the committee that I look after myself is package integrity. So this is the subcommittee that has all the CCIT standards that are relevant to our industry today. As you can see, there are a number of standards that sit under it, and as I plan to talk about in my presentation, I plan to talk about F2338, which is the vacuum decay standard. And then in section 2, I plan to talk about F3169, which is the vacuum deflection standard. There are other methods and other test methods within the industry that are currently in use and have a lot of use within our industry, but don't actually have an associated standard as of yet. There are 2 work items that are currently underway, one for high voltage leak testing and also one for force decay as well. But there are obviously other inspection methods that at the minute don't have associated standard. Probably I just want to highlight a couple of columns actually while we're here, is that I've highlighted destructive. So while we see the test method as a destructive or non-destructive terminology, and also then the other column is deterministic or / probabilistic, and this is the terminology and the categorization 1207, USB 1207 use. They categorize a test method in really in two categories. Well, it's deterministic or probabilistic, and I will cover that later on in my presentation. Okay, so hopefully that gives people a better understanding of ASTM, the structure around ASTM, and how a standard is made. I will now go on to talk about USB 1207, and then the last part of this, I will talk about the vacuum decay ASTM standard as well. Okay, so USB 1207. USB 1207 is around container closure. There are a number of USBs that exist that help control and legislate around container closure, but 1207 is the one that's focused on package integrity. As you can see there, I picked out seven USBs here. Okay, so USB 1207. So USB 1207 is actually split into 3 volumes. The 3 volumes are 1207.1. This talks about test method selection and validation. 1207.2. This is actually focused on the testing technologies. And 1207.3. This is the part of USB 1207 that talks about the seal quality tests and the techniques. Okay, so let's look a little bit deeper at 1207.1. So 1207.1, as I've said, it is around the product life cycle, test method selection, and validation. When we look at the package integrity testing and the full life cycle, 1207 then breaks it down into three parts. It's the development and the validation of the package. It then moves on to routine manufacture, and then once it's in routine manufacture, it looks at the marketed product stability as well. So that's really the 3 parts that cover the full product life cycle of any product released to the market. In terms of the test methods selection, they consider lots of things, whether it's inline or offline, whether it's probabilistic or deterministic. They talk about the maximum allowable leakage limit. There are, I think, 10 or 11 points that in terms of the test method selection and validation that this covers. But I won't go into them all today, but hopefully it gives you a little bit of understanding. Okay, so the volume 2 then, volume 2 again is more around the testing technologies. And again, the main theme within volume 2 is that it's looking at each of the testing technologies, and it's categorizing them into two categories, whether they are well, it's a deterministic method or well, it's a probabilistic method. It then goes further to talk about and how is a deterministic method described. One of the ways of describing it is it gives you a list of points. So whether it's highly instrumental, it gives you a qualitative or quantitative test as an example. It's the risk of error is very low, for instance, in a deterministic test, versus the risk of error could be a lot higher in a determinant or probabilistic test, as an example. And then lastly, in 1207 is the seal quality check. So this portion only checks the function of the seal quality. So it describes a way of categorizing and monitoring seal quality, but it's not a whole package integrity. It calls out a number of ways of testing, but the majority of these maybe the exception of ultrasonic are actually destructive to a certain degree. Certainly the burst test is a destructive test, and the two types of that, whilst the internal pressurization or just the pressurization with restraining plates. And lastly, then the seed strength peel test itself is a destructive test. Okay, so that for us that covers very quickly 1207. Okay, next, what I'm going to do now is I'm going to pick out one of the ASTM methods, and that will be the principle of vacuum decay. Okay, so the principle of vacuum decay. So ASTM F2338. So in terms of the terminology, the standard itself is F2338. -09 is the notation that tells you that the standard was originally developed in 2009. And then anything you can see in brackets, so 2020, as an example, this was the last time the standard has been approved. We should see the next revision of the standard being released now in November 2024, and that will see us extending the scope of the standard to include the use of a flexible test head versus just the original rigid test head. So that opens the scope to allow us to test using a flexible membrane type test, which will align directly with the standard, and it allows us also then to test a bigger range of sachets and pouches that will allow us a lot align directly with the standard. I've just shown you a quick excerpt from the standard here on the left hand side, and as you can see, I've also shown you what a typical pressure curve looks for the different types of passes and failures within this test. So I now plan to look at each one of these in turn. I will describe the pass, the gross, the medium, and decay. I also will then call out each of the recipe settings. So the fill time is pretty self-explanatory. It's the time allowed to generate a vacuum. The target vacuum is the required threshold that you need to reach to pass or fail, equilibration time and test time, and so on. You can see it's pretty self-explanatory. So now what I plan to do is describe each of the testing scenarios in turn. I will start with a good part. So a good part. So what we're looking for is that has the good part reached the target vacuum within the fill time, which is V1, which it has. Has it then stayed above what we call the reference vacuum the whole time during the test, which it has, and has the difference between V3 and V2 be within an acceptable range within the test time, which it has. So that would show me that this is a typically good part. Next, what we're looking at here on the screen is a gross defect. And a gross defect, how we categorize a gross defect is any part that doesn't achieve the target vacuum within the specified fill time. So that's the first, it's failed at its essentially its first pass and fail threshold. We go on then to look at a medium-sized leak. So a medium-sized leak in this scenario is anything that has passed the target vacuum, so reached the target vacuum, but during the equilibration phase, equalization phase, it's actually dipped below the reference vacuum, and thus is a failure. And then lastly, what we have is what we categorize as a decay leak. So I've traced the good part and the decay leak on top of one another. The dashed line is what a typical decay leaker looks like. So as you can see, a decay leaker actually behaves very similar to a good part through V1 and also V2, and we only see the difference in this, and it will only fail on the last part of the test, which is the decay limit. As you can see, it starts to decay over the time. So that's all the testing types categorized. And what I've just highlighted here is the different container types also that you can test using this method. So you can do vials, ampules, pre-fill syringes, bottles, blow-fill seal, even form-fill seal to a certain degree, and sachets and pouches, especially now that the new update to the standard is coming out in 2024. So basically, it works both for rigids and actually some flexibles, depending on the contents and the makeup of the container itself. But what we found is a very popular testing method within the industry, and used across a broad range of container types. As Evelyn maybe highlighted earlier on, the system that we produce is our multi-queue. Our multi-queue allows us then to run the vacuum decay test. It also allows us to run a vacuum decay test, both with a rigid tooling attachment, but also the flexible membrane attachment. In addition, the multi-queue is a multiple test type tool and device. So it allows you also to run other testing types, just not only the vacuum-based tests, but also a pressure-based test as well. Okay, so I want to talk about part B now, if that's okay with everyone.
Okay.
Yeah, maybe what I would suggest is, anybody have any questions from part A? Do we have any questions on Zoom?
No questions for the time being.
Okay, perfect.
Okay, I would suggest you to go on, and at the end we'll have a general Q&A session.
Perfect. Okay, so in this section, depending on what we can do is depending on the time frame, we will focus on the blister testing first. But if we have enough time, what we may do is we may also talk about the forced decay method as well. But it really depends on how we feel for time, I think, and when we're on time or not on time.
Okay, that's fine.
Okay, perfect. Okay, so in this section, then what I plan to talk about is the F3169, which is the vacuum deflection ASTM method. The vacuum deflection method then, so the basic or the full title is the standard method for leak testing in blister packaging by vacuum deflection method by laser measurement. As you can see, the scope, the ASTM method itself is broken down into the scope. Then you have any reference documents, terminology, and then we go on to describe the method itself. For this, what we've defined the scope as is for non-porous blister packs sealed with a flexible film, such as used in pharmaceutical blister packs. So this is the typical application for this type of method. We typically have a rigid or semi-rigid base, And those are typically what a pharmaceutical blister pack is made of. So whether that's aluminium, whether that's a PVC-based material, or even some of the laminate type materials with to create a higher barrier. And then more recently, what we've seen is that we've been requested to test other things and new materials on the market, including the mono blisters as well. So the recycling blisters that are available on the market. The basis behind this recipe or this method is that what we will do is we will apply a pressure and a vacuum to the blister pack, and what we do then is we measure this response with a laser-based measurement device. From that, we will be able to determine the type of failure, not unlike the vacuum decay test as well. So this next section, I'm going to describe the principle of the vacuum deflection method, and then from there, what we can do is we will break it down in terms of describing how it works, and some of the features there as well. So what we have, if you imagine in its very basic terms, we have a vacuum chamber, and inside the vacuum chamber, for instance, we will show you that we have a sensor, a laser-based sensor. We have just a gauge to show you what was happening during the test. And then down the right-hand side, you can see the various phases of the test. So the first step is we will load the blisters. The second step, we will do our first measurement scan. We will then apply a vacuum, do our second measurement scan. We will wait for a certain amount of test time. We will do the third scan, and then at the end, we will vent the vacuum and display the result on the screen. So the test itself is typically broken down into two parts. What we would call this is the gross phase. So this is, we're looking for large defects. So whether that's a large slit or a large, 200 micron pinhole or a weak seal, this is typically where that is detected during the leak test. And then the second part of the test is where we look for the medium and small size holes. And the testing time will allow us to do that. And then we look for the difference in the third scan. Okay, so the first step, as I described, is we load the blisters into the vacuum chamber. And we'll then do a measurement scan. The next stage is that we will apply a vacuum. And as you can see, what you should expect when we apply a vacuum is that we should see expansion of the lidding foil. So the lidding foil is the flexible part of the blister pack, and it should expand due to this difference in pressure or due to when we apply the vacuum. At this point, then we will do a second scan. And as you can see, that the one that I have highlighted here is a gross failure. So basically, a gross failure is a pack or a pocket or a cavity that has not responded to when we apply a vacuum. So on the application of vacuum, we have seen no movement here on this cavity. And this would tell us that this has a gross or a large type defect. So once we've done the second scan and once we've identified this as a gross failure or gross defect, we then move to the second phase of the test. The second phase of the test, we're holding the vacuum for a predetermined test time. And typically the rule of thumb here is that the longer that this hold phase or this test time, the more sensitive the test will become. A typical blister pack, we see the typical test cycle time in total, and all the steps here highlighted in this chart, is typically around 30 seconds. But if you want to be a real sensitive test, it could be up to 1 minute for the full test cycle. And again, it will depend on how sensitive you want the test to become. So as you can see, during the test, we're just holding the vacuum for a certain amount of test time. And what we should see is during that test time, any cavity with a small defect should start to deflate. And then lastly, what we will do is we will do our third measurement scan. And what we're doing is we're looking at the difference between the second and the third scan. And we know that this is different between the second and the third. So at this point, we would identify this as a decay failure. The last part of the test then is where we would vent the vacuum back to atmosphere. So around about 1,000 millibars absolute, as you can see. And then the system itself would display pass or fail for each cavity as a result. So just very quickly in summary, as you can see, we've highlighted 3 columns here and the 3 types of a determination from the machine. The first column, you can see reference, vacuum, and reduce. This is where we would identify this as a decay or a small defect. In the center, you can see this is what a typical good pack will look like. And then on the right-hand column, you can see that the gross defect basically hasn't moved to begin with, and thus will not move at any phase during the test at all. Okay, so where we're at and what we want to talk about next is we just want to highlight some of the features of this system. We will then show you what a typical test screen looks like with some blisters loaded in, and then we can go from there. So the system itself, one of the key features of the system is it's totally toolless. So there are no fixed tooling required. The only tooling or only part of the recipe that you need is you need to teach the system the outline of the blister and some of the regions of interest. The system itself, as I said, can detect all types of failures. So whether that's a channel leak or a weak seal, a defect in the lidding foil or defect in the base material, the system will identify each of the leaks the same. And the system itself has a sensitivity that can go down to 5 microns or above, actually. As I said, it's got a rapid test time, but typically there's a typo there. But typically, a typical test time is anything between 15-20 seconds up to 1 minute. We have a large 18.5-inch touchscreen that is easy to use, and the system itself is running on an SQL database, so it gives us the ability to store the data in a CFR 21 Part 11 compliant way, and we also have other features like if you like to connect it to your Active Directory or a central server, or even if you have an MES system and you need to connect, the system has the ability to do that as well. These three pictures just highlight what the typical system looks like. It's a benchtop system with the drawer at the front. You can see that, as you can see, that every pocket will get a pass or fail result for each. And every pocket will be green or red depending if it's passed or failed. And that will then correspond to the exact layout, as you can see, as the open drawer on the far right hand side as well. Okay, so I just want to then look at some containers then, and then what we can then do is we can maybe just do a time check, guys, and to see if we have time to cover any more content or not. So in terms of container type, what we have is that we looked at all the container types available in the market, and what we've tried to do here is map out our various systems and various test methods that can then align with the various container types. So for blisters, as I've just talked about, we would use our Vision Scan vacuum deflection recipe. For rigid trays, we would use our force decay product, which I don't know if I have time to talk about today, but I may do. For sachets, we would either use our force decay recipe or the new updated ASTM flexible test head. For bottles, we're typically using a multi-Q, and it depends on the contents. If it's oil-based or something like that, we will use pressure decay. If it's solid-based or powder, or even or a water-based liquid, we will typically use vacuum decay. For vials and ampules, again, depending on the contents, we have two options with the multi-Q, whether it's pressure decay or vacuum decay. And the same goes for pre-filled syringes. It really depends on the contents and the size and shape of the container. And then lastly, not all containers fall in the category of a blister, a rigid tray, a sachet, a bottle, a vial or ampoule, or pre-filled syringes. So we call this special because these are other container types that are used within the market that sometimes require testing as well. And we would typically use our Vision Scan or our version of our Vision Scan or our multi-Q, because our multi-Q again has many test types we can employ to help customers align directly with that as well. Okay, guys, so that covers the main part of the content. I just want to maybe pause here to see if at this point, does anybody have any questions?
Okay, thank you, Philip. Any questions for the audience, from the audience? So first, thank you very much for your presentation. I find it very, very interesting. So let's wait for a while. Let me remind that the multi-Q instrument will be available in Rimini at the Symposium. So for people interested in looking at the actual instrument, you can visit the Emme stand, and you can have a practical demonstration of the multi-Q. So waiting for questions from the audience, just a couple of curiosity for you, Philip.
Okay.
About the vials, can you test any size of them, or are there specific sizes you can test?
So let me just forgive me, forgive the scrolling. Okay. So yeah. So in terms of size, the only limit, the only limit. So there's no real limit per se. So the limit is physically, can you physically lift the tool and attach it to the top of the test head? You know, so in terms of, does it become too heavy to manually move the tool? In that case, what we would recommend is you set the tool beside the system, and you can test it then beside it. So for instance, we've tested a 2-liter bottle, you know, in terms of that size, can be tested, no problem. But in that case, the tooling will actually sit at the side of the system, and we attach the tooling with the pipe. But in terms of, you know, in terms of the market, what we see on the market today in terms of pharmaceutical vial, yes, we can test the full range and all sizes from the smallest up to the largest vials available, no problem.
Okay, thank you. There is a question from the audience, from Alessio Molinari. The best technique, vacuum/pressure for vials for parenterals. 5 grams of powder into 50 ml glass vial. What is the best technique for a situation like that?
So yeah, it depends. It depends on a couple of things. It depends on the overall content. So a dry powder, the one thing we would advise is it depends on the hole size that you're looking for, the defect size. So in terms, maybe the smaller defect sizes, you would use pressure, because what happens is the powder has a tendency of blocking the defect, or the reverse. If it's not so small of defect you look for, then the idea being you can use vacuum. But the one thing I would say is that the system can do both. So we're not limited just to doing vacuum or pressure. The system can do both if you need to.
Okay, thank you. I think this answers the question exhaustively. I think so. Another participant is asking, thank you, Alessio. Another participant is asking, can it test protein-filled products?
Can it test? Sorry, I didn't. You broke up.
Protein-filled, so biotech.
Yeah. So protein and so what we would advise, so protein and maybe larger molecule products. Again, the theory being that we would use pressure decay in that case, simply because what will happen is the protein-based products are quite sticky, and also the maybe larger molecule products are quite big, and they would also have a tendency of blocking defects if you're using vacuum. So the idea being that if you have a defect, it's easier to push pressure inside than trying to draw the protein or the larger molecule outside. So yeah, we can test protein products, but we would typically recommend using pressure decay and not vacuum decay.
Okay, thanks. Clear. Any other questions? Well, talking about the vision scan.
Yeah.
Can you determine the size of the hole detected, or just a rough idea, or how precisely?
So we can tell you in terms of the vision scan, we can tell you or make an estimation of where the hole, you know, what range the hole will be in. So we will say that we can tell you that, for instance, the defect is bigger than a certain size. But can we tell you that the defect is 23 microns versus 25 microns? No, we can't. But we can tell you it's at least bigger than 20. At least 20 microns or bigger, if that's what the recipe has been set to.
Okay, thank you. Another question from the audience. The multi-Q or another technique could be used also just to control the vacuum level into vials that contains freeze-dried products.
So again, freeze-dried or lyophilized product, we can leak test. And again, it depends on the defect size that we're looking for. We would typically recommend for lyophilized and freeze-dried product that you use pressure decay. But what I would say is we will typically assess the product when we see it and make a recommendation. But yeah, we can certainly test them if required.
Okay, thank you. Any others? Okay, no question for the time being. And are you, just a curiosity, are you the only ones using the 3D technology?
Yes. So the 3D technology is a patented technology for us, and we're the only company that uses this technique within the industry. Yeah.
Okay. So other questions? So I can't see any other questions. So, sorry. What about paper-based leading foil? What about alu-alu?
So I'm assuming you're talking about vision scan. So vision scan can test the full range of materials available today, whether it's paper backed or alu-alu or alu-PVC or Aclar based materials. And the system can test anything that's available on the market today that certainly we have an experience of. SIFA as a company have been selling blister leak testers since 23 years, 24 years now. And we pretty much can test most things that we come across now on the market, because we've developed and adapted this technology for the last many years to do so.
Okay, thank you. So another question, how can I choose the acceptance criteria for testing a parenteral glass vial product?
So what I would say is that yeah, so what I would say is to use you need to use your stability data if you have any, to drive the need. But also then there's lots of material available from places like USB 1207, for instance, will give you guidance on maximum allowable leakage limit. But really, the one thing I would say, most people will use a risk-based approach. So they will use a risk-based approach to say, okay, we need to test to this hole size, because the probability of detecting that hole size versus being able to produce it as well, versus okay, what is the likelihood and the frequency of something like this happening. So yeah, it's a, you know, when looking at selecting a test method and a test recipe and setting sensitivity, it's a holistic approach that you need to take. So it's just not one from one side. It's looking at the product. It may be looking at your stability and your development data, but also it's looking at the available testing methods available, but also the practicality sometimes of how you implement them as well, because some methods are more difficult to implement and maintain than others. So as I say, it's a holistic approach you need to take.
Yeah, sounds logical to me. Okay. Well, while waiting for other questions, I would ask all the speakers to show up. I would like also to remind that between AFI and ASTM, there is a good cooperation. I know for sure that ASTM people are very open. So if someone likes to participate in some subcommittee, working group better, I think that through AFI, this is possible.
Yeah, I would agree. So in terms of the ASTM, the one thing I would say is that the ASTM is open, always open to new members. It's not limited. You know, you don't need to be American or associated with anything American. So you can for sure join and participate. ASTM themselves have rebranded themselves a few years ago as ASTM International. And they see themselves as an international standards committee, not just American. And I would say as well, when you think about it and look at it, the ASTM standards are always referenced, you know, not just within the USA, but within Europe, within Asia as well. Many people use them and reference them because they have a really good coverage of our industry.
Yes, correct. I confirm. Last year, we participated in a subcommittee for lyophilization. So here from Italy, we tried to give our contribution.
So the other interesting thing, I actually forgot to put it in my presentation. So the ASTM, the FO2 committee, will be hosting their FO2 committee in Bologna in October.
Okay, great. I didn't know.
Yeah. So typically the 2 days are always hosted somewhere in the USA. But what the committee normally do is once every 2 years, they will come to somewhere outside the US and hold the 2 days of committee meetings outside the USA. So this year, we're holding FO2 in Bologna, and I think it's around the 16th or 17th of October. But what I may do is I may maybe tag that information onto the presentation as well.
Yes, please. Thank you. So I don't see any other questions. So I would say that we can finish here this webinar. I thank you all the speakers, Stefano, Evelyn, Philip, and also here the organization, Elena, Sandra, Aldo, because it's up to them, thanks to them that these webinars can be successful. So let me say, see you in Rimini.
Yeah.
Okay. So goodbye. Thank you. Sorry, another question. Okay, thank you to all. Thanks. Thank you to all participants, of course.